Okay, so uh, this is the web panel, uh, PR energy storage. It's batteries versus fuel cells, or is it batteries and fuel cells? And today I have with me Michael Koskin from Doosan, Gabriel Perez Sepulveda from Blue Planet Energy, and Daniel Bourne from Sandia National Labs. We're happy, frankly, to kick off. Hopefully I'm not getting feedback. I am getting feedback. That's weird. Um, with that guess out, without further ado, Puerto Rico is going through a first of its kind transformation of a first world designed energy system from something that was centralized, I guess still is technically centralized, command and control, to something that will be the leading distributed market for renewables and different types of technology. And in particular, energy storage is going to become critically important to the resiliency and the change in that market. So looking out, you've got a big future, and you're going to see additions, if only just by the plans in the draft integrated resource plan, of almost as much storage capacity in 3 years in Puerto Rico as currently exists in the United States. The energy policy law is on the governor's desk today, and we're expecting him to sign it and begin the transition into a new form of market. The regulator has actually shown some fortitude in kicking back the first draft of the integrated resource plan for a number of reasons, but one of them was not taking into account enough the potential of high amounts of behind-the-meter distributed energy, solar and battery storage for certain, but also CHP and other types of grid-connected microgrid energy that we expect to be put in place in large volumes over the course of the next decade. So with the distinguished panelists we have here today, we thought we'd explore a bit about that market, its implications for the broader United States and the world, and take a closer look at the two of the leading technologies, batteries and fuel cells, and trying to determine whether there's a winner or a loser, or whether we really just have two winners here. So with that, I'd actually like to ask the panelists to introduce themselves. And I'm actually going to start with Daniel Bourne from Sandia Labs. So Daniel, if you could take a couple of minutes and talk about yourself and Sandia.
Sure. So my name is Dan Borneo, Sandia National Labs. I work in the energy storage program. So what our charter is at Sandia, we basically look at everything from soup to nuts. We look at the technologies, developing new battery systems. We look at the materials that go into the battery systems. We look at the safety of the battery systems, doing a lot of work with lithium ion, trying to figure out how to make a better version of them that's less flammable. Then we go into the power electronics, and we're working on the new phases of the power electronic systems. And then we go into analytics, and so analytics and projects. And so that's where the area that I focus on is we develop projects with states, utilities, developers, and as part of that developing a project, we go in and we do an analysis. We have services. I presented some of the tools that we use at the NELHA tool workshop that was held in Puerto Rico a couple weeks ago. And so we go in and we do an analysis of a system to determine what power capacity that you need for an energy storage system, for the application and what would make sense, and also the duration of that system. And then once we have that determined, we actually help people develop the RFIs, RFPs, down select the vendors, and then go in and we support the projects all the way through design, construction, commissioning, and then into operation. So that's basically what we do. We're led by Dr. Emery Zook from the DOE Office of Electricity Stationary Energy Storage Program. And I've been in this work here for 12 years. Went from energy storage being very, very low key, very almost nothing, a solution waiting for a problem. And then all of a sudden, when PV and wind started to take hold, somebody made the aha moment that, you know, at a certain penetration of renewables onto the grid, it could become unstable. And then energy storage found a home. And since that time, it's just been all gung-ho, finding applications. The costs have come down, the safety has increased, and all of a sudden now energy storage has finally found its footing.
Great. So for those keeping score, the internet has come back, and so I've switched from my phone back to my laptop. Thank you very much, Dan. So Gabriel, if you could talk next, just briefly. I know Michael's got a few slides to show, so let's have him go last.
Yes, of course. Thank you, Thomas. Thank you for having this panel. Very interesting. So my name is Gabriel Perez. I work with Blue Planet Energy. It's a storage battery company. It's a Hawaiian-based company. It comes from the Blue Planet Foundation, which were the advocates of moving the 100% renewable energy efforts in Hawaii, and also they're supporting Puerto Rico with that effect. I have been in the industry around 11 years. I have been living all my life here in Puerto Rico. Currently, I'm in the board of directors of ACONER, Renewable Energy Association here in Puerto Rico, also supporting Fundación Borincana here in Puerto Rico. So I have been seeing in the past 10 years, I have seen how the industry has been growing, then has been taking different shifts, okay? Before the hurricane, everything was connected to the grid, just lowering their energy bill, wanted to save some money, but everything changed after the hurricane. Batteries, nobody was doing batteries here before the hurricane. After the hurricane, the battery industry started kicking in because of necessity. I lived during the hurricane. I was here. I saw the problems that we had. The first 2 weeks were a total chaos. There was no way to get even water, fuel. It was a disaster. So I saw the humanitarian crisis, and what I'm seeing is that batteries have been playing a good role after the hurricane, but building resiliency. We have Puerto Rico was not prepared for this hurricane and any other hurricane. Okay, the last hurricane that we got was 20 years ago, so we were not prepared. We were not even talking about resiliency. So we were hit, and we are learning from that mistake. So currently we're seeing a lot of movement in the battery storage, and I will keep on talking and explaining things that we're doing. So thank you.
Fantastic. Thanks, Gabriel. And Michael Koskin from Doosan Fuel Cells. They actually have a space station and other types of uses, and now in kind of the industrial world. Some people are familiar, others maybe not. To the extent they are, maybe they're familiar with Bloom or a few of the other companies out there. Maybe you could take a couple of minutes and just talk a little bit about fuel cells. So the folks on the web panel call, and people see the recording can have a grounding in your technology.
Sure. No, thanks. Thanks for having me. I appreciate it. So I'll just go over at a very high level who Doosan is and then what a fuel cell is. I mean, Doosan is a large global South Korean conglomerate. We're a $16 billion organization with 35,000 employees, most outside of Korea. We're in a whole host of businesses, whether it's energy storage, fuel cells, wind, portable power. We have boilers, gas turbines. Our biggest U.S. brand is Bobcat. Bobcat Trucks is a Doosan brand company. We actually used to be United Technologies many, many years ago. This was the technology that UTC founded. We were on the Apollo and Space Shuttle missions in the 50s and 60s. We're now stationary. We have over 400 employees here in South Windsor, Connecticut, where we manufacture the fuel cell. Over 150 megawatts installed worldwide. And if you look at the picture on the lower right, that's our newest addition. That's a factory in South Korea where we have duplicated, doubled our production from 150 to 300 units annually. This is a brief history, as I said, from the 60s, the Apollo missions, and then in 2014, Doosan took over the United Technologies assets. Basically, in a nutshell, a fuel cell is an advanced combined heat and power system. It takes natural gas, compressed natural gas, LNG, what have you, converts it into pure hydrogen, and then through an electrochemical process with no combustion, creates electricity and waste heat as a byproduct. That heat, like CHP, can be used for a whole host of uses. It could be used for boiler preheat. It could be used to heat a swimming pool. It could be used for chilling, which would probably be most effective in Puerto Rico. We're the most flexibly deployed fuel cell. We could be on rooftops. We could be indoor. We could be outdoor. Multi-megawatt sites, whether it's 1 unit or 50 units, we can find a path. Environmentally, there's an enormous amount of benefits. So we're air permit exempt in all 50 states. Additionally, in Puerto Rico, we are a class 1 renewable. We are treated the same as solar and wind. We have no NOx, no SOx, very little bit of CO2 emission, and we're very quiet. So again, there's no combustion. It's just the hiss of gas passing through the machine in a cooling tower. You can also get lead points. I think, for today's discussion, I think you'll note that we're the only fuel cell that's dispatchable. So our fuel cell can load follow, which means we can mirror the load of any facility, ramp down to 0 and get up to 460 kilowatts per system. We have a whole host of customers in many different industries. Incentive-wise, I think it's important to note that Puerto Rico is eligible for the federal investment tax credit, which means that if you invest in a fuel cell, you get a 30% investment tax credit on the equipment and the installation. The other states that we tend to do business in are Connecticut, Massachusetts, New York, and New Jersey, and a little bit of California, where electricity prices are high. There's almost nowhere higher in the contiguous 48 states as Connecticut, but I think in the grand scheme of things, Puerto Rico, Alaska, and Hawaii have the highest electric rates of the United States. Just to get the conversation going and thinking a little bit, we have a couple customer profiles here. We do multifamily housing, we do hospitals, industrial, pharma, and at a high level, I just wanted to kind of share all that.
Sorry, if I can get myself unmuted properly. Michael, thanks very much for running through that. I think that that definitely helps. So I think that the first thing I'd like to hear from both of you, since you're both looking at the Puerto Rican market, do you see as much opportunity there as maybe others do? And I sort of led on at the beginning of the of this segment. What do you think your penetration rates and other things are going to be? I'd throw that out there to whoever wants to pick that one up first.
Yeah, so I certainly think that there's a tremendous opportunity in Puerto Rico. I think certainly behind the meter projects at hospitals, in the biotech sector, in the aerospace sector, I think there's a real need for cheaper, cleaner, more reliable power. And I think it's just a matter of getting that first project on the island. I know that Gabriel had mentioned that there's already a lot of CHP going in on the island. I think what's fascinating and what will continue to get more interesting is that because we're part of Puerto Rico's renewable portfolio standard and this standard to get to 100% renewable by 2050 or 2040, they could technically do it with natural gas fired fuel cells, or natural gas powered, I should say. There's no combustion. So moving ahead, I think whatever happens with PREPA, and if there's a renewable energy credit available in the future, it's going to be very beneficial to having fuel cells on your property and monetizing that asset even beyond saving money on the electricity.
Great. Gabriel?
Yeah, for my part, there's tremendous also opportunity in the battery market. Again, after the hurricane, we were not prepared. We were not even thinking about batteries, but leaving what we, with Maria and Irma almost 2 years ago, that we have the necessity of the ATMs not working, communities that because there was no electricity, the water, they didn't receive clean water, and then Osteoporosis, that disease started kicking in inside the island, and that made that killed a lot of people here in the island. So we're getting prepared, but we're getting prepared right now thanks for the non-for-profits. They have been supporting a lot the island. If it was not for the non-for-profits, probably we were just be talking and nothing happening. As it right now, we're doing resiliency projects in schools, in 125 public schools, where they were used as shelters during the hurricane, and we're putting 2 microgrids with battery storage, and also in some cases, we're using the generator as a backup. Okay, so if we're doing resiliency, we're not just talking about solar batteries. We need to start thinking of other technologies. That's what builds a robust resiliency. So there's some properties that have generator, and that generator can charge the batteries. So we have the panels, we have the generator, and then we have the utility. So that's happening currently. Also, we're doing microgrids projects with batteries in health clinics. Also water pumps, non-PRASA. I can show you very quickly here a project that we just did. I don't know if you can see my screen.
If you click share at the bottom, we should be able to see it. There you go.
Yeah, I just want to show you an example of what's happening here in Puerto Rico. This is a project that we partner with a non-for-profit water mission, and we call it non-process. These are water pumps that are all around the island, and they're not connected to the water utility company. Yeah. So there are wells that are done in the land, and they just connect power from the grid and use water pumps. So if you don't have power, the water pump will not work. So you will not have any power. So we're using the batteries as a resiliency to have power in those communities. So a lot of things are happening here in Puerto Rico after the hurricane with storage. It's a little bit sad that it's taking a little bit of time. It's taking time, the funds to get here, but people have the mentality, and now they're getting prepared, and they know that they have to be prepared for another event.
So Daniel, maybe you can comment on this. How should we think about breaking down the market for storage? I mean, I tend to think of things in Puerto Rico as being split into kind of grid connected, for power systems, commercial, industrial, and then I think about, kind of residential, small business, community. Is that the way we should think about, segmenting from a storage standpoint, or are there other categories we should be thinking about?
Yeah, that's a good question. So, well, we're doing a lot of work. Sandia and other DOE entities, DOE labs are doing a lot of work down in Puerto Rico right now, doing a lot of analysis. You know, they got the last mile where they're looking at the areas they got their power back on, the last on the list. You know, you got the industrial microgrid part. There's also the project in Bijava, where they're trying to tie the 5 cities in that area together into a microgrid. Basically, they're going to develop their own municipality power generation. And so in each one of those, you know, there's going to be the 3 components, as I've mentioned earlier when we were off the air. But, you know, so you have your renewables that are going to be there. You don't need to worry about a supply line, you know, your energy storage that's going to be there to support your renewables. And that's going to be the lion's share. But also, because of the costs right now of the energy storage, you should also consider a traditional generation. And so what I'm curious about learning from Michael more is how the fuel cell, since it is a natural gas-based system, you would have to pipe gas or ship gas to your locations, but you know, how you could utilize the fuel cell into that triad, if you will, to provide a microgrid. Now, that would give you your microgrid. You could stay off of PREPA if you had to. Now, it's always nice to have PREPA. I don't quite understand how that's going to work out with the state of PREPA. You know, if PREPA is always going to be there, if they're going to privatize it, if they're going to do away with it. I don't see them doing away with it. But so somehow there's a marriage there. And I don't know, did I answer your question, Tom?
Oh yeah, for sure. And then you kind of led right into the next one, which is there's currently, well, it'll be controversial for a while, but I mentioned in the lead-in the integrated resource plan and the rejection by the regulator. Told them to go back and think again and come back in 30 days. But one of the controversies there is that the plan currently calls for a tremendous amount of new natural gas importation infrastructure. One landed regasification plant, and I think 3 or 4 offshore gas plants to bring gas in and around the island. Some of that will certainly get done, but there definitely will be a pushback. I guess again, adding on to what you were saying and the question that you were asking, Michael, is that when you think about certainly what you're doing as a renewable, how reliant is your future market, do you believe, to the ability of PREPA and the kind of the natural gas folks to actually get that infrastructure built?
So I think those are good questions. I think we obviously need natural gas to put through the machine, but you could always store LNG or CNG on site 72, 96 hours, what have you, to make sure that machine continues to get fed during an outage. I think that what we're talking about is, to the Doc's point, is that we could be part of the microgrid. We're the base load generation for the microgrid. So you can use the solar to peak shave. You can use the batteries during the outages. I mean, you need a comprehensive energy solution to solve Puerto Rico's problems. And I think, because they have maybe a kind of a clean slate, there's an opportunity for us to become the base load of the island in a clean, effective way, and then have solar and battery storage help with the peak shaving and smooth out some of the heavier usage parts of the day.
So I have a question, Tom, if I could ask it. So Michael, when you're saying the base load, are you actually saying that you would replace the coal-fired power plants with this with your fuel cell?
I mean, it's a possibility, sure. I don't think that's our goal right now, but I think in the future, you certainly, in Korea, for example, an island, a region that has no natural resources, so to speak, they are heavily reliant on fuel cell generation. And the majority of our utility business is in South Korea. We have our largest installation is going to be a 50 megawatt power plant and a district heating loop. In addition to that, that's going to help heat the local city nearby. Right now, I think all we're really talking about is behind the meter generation at a couple target verticals and being part of some microgrids. I think costs have come down very dramatically over the past 10 years to the point now we really pencil out and make sense, even if gas is $10, $11, an MMBTU, which it is. So again, with pricing in Puerto Rico being 23, 24 cents for what's not the most reliable power, you could reduce your costs and get something that's much more reliable in a fuel cell.
Yeah, no, I think that makes a lot of sense. Obviously, in Puerto Rico, what it would offset, if you're thinking about that industrial, microgrid sector, is probably the on-site diesel generation, as opposed to kind of the grid coal. You could imagine using fuel cells for more distributed balance, replacing kind of the direct gas-fired peaking plants that they're talking about. There's like 27 to 33 in the IRP that have all of the gas transportation infrastructure. So they would help with desynced regional microgrids, but you could think about it in terms of fuel cells rather than peaking plants, and you could actually do them effectively. I'm kind of making a statement rather than asking a question, but I think you could, in theory, not just have a couple of smaller gas-fired peaking plants around the island to balance the planned regional grids, but you could actually within that have, with the same sort of gas infrastructure and without necessarily all the emissions and with the benefits of heat rejection and chilling, have more of these facilities within the regional grids powered by natural gas.
So I have another question, Tom, if I could ask. So Michael, I'm not picking on you. I'm actually here to learn because I don't know that much about fuel cells, but you're actually coming onto this panel. I started thinking about it and thinking about their application, and it's kind of opening up my eyes a little bit to other possibilities. So my question is, what is the gas usage compared, say, to a natural gas generation, traditional generation, or a natural gas fuel cell, given the same power output?
So we're more efficient, right, than a traditional CHP. Our electrical efficiency is around 42 to 44%. If you use some of the waste heat in chilling in Puerto Rico, for example, or even up here in the Northeast for heating, we can approach 90%. And I would say that a lot of the incentives up in the Northeast are efficiency driven. So we have to hit at least 60% HHV to qualify for a lot of these incentives, which we do, which is much more, which is more efficient than the existing grid. In terms of annual gas usage, I mean, we're using about 35,000 MMBTUs annually per fuel cell. It's a lot of gas, but again, it's a firm baseload gas, and I think it's going to help drive pricing down the more you proliferate CHP, fuel cells, and other gas-fired generation throughout Puerto Rico.
So if you're using 35,000 for a given output in your fuel cell, how much would a natural gas generation station use given the same output?
Probably to 10 to 20% more. I mean, we're much more efficient than they are. We don't, and again, we don't combust. It's all electrochemical reaction.
Yeah.
Okay, so you're basically saying not only are you more efficient, but one-to-one, you put in the natural gas you put in and the energy you get out is roughly equal to the natural gas generation, but you're more efficient. So you're going to actually have.
We're going to use less gas, and we're going to be cleaner. We're not going to combust, so there's not going to be CO2 or any NOx or SOx or particulate matters to worry about.
Yep. And I guess as you qualify for renewable, it should be interesting. There's also yet to be interpreted, but on the microgrid side, if you're going full CHP, you're okay. If you start including renewables, there's a little program in there that says you have to go 75%, a kind of renewables and storage, solar and storage. We'll have to take a closer look at that somewhere, but as you qualify, that might be interesting. See, Puerto Rico's the Wild West. There's a lot of opportunity, a lot of fun, but also a lot to be defined. In terms of, I think the batteries have certainly had the most of the play, and will continue. Gabriel, I know Blue Planet's Blue Ion system is somewhat unique in terms of its configuration and source choices. Very different from not very different, but different from Tesla and others. And there are a lot of different technology choices. But I think, again, making a speech, very suitable for home and small business, maybe less so for grid connected or industrial, just depending upon the depth. But can you talk a little bit more about your battery technology and the advantages and the idea of what I would call breadth and depth? So in terms of charging up the battery, how long can it disperse, that kind of thing? I think you're on mute. Gabriel, you're on mute. There we go. There we go.
Okay, can you see my screen?
I can.
Okay, perfect. Sorry. So yeah, from the Blue Planet Energy, the Blue Ion 2.0, it's a product that right now we're using here in Puerto Rico. Eventually, we're gonna bring a high voltage product, but this product is a 48 volt battery systems. It can be installed AC coupled, DC coupled. And here in the screen, you can see it's a super high performance and rapid charge. An example, our battery, you can charge it twice as fast as the competition, Tesla. Okay, we could cycle our battery 100% depth of discharge, and we give 8,000 cycles. We're talking about 20-year life expectancy of the battery. And we're talking about a lithium ferrous phosphate, which is the technology, is the safest technology for lithium ion. It's more expensive, and the technology, the thing is that we really define the lithium 100%. That process that it takes to refine our lithium, it's very expensive. And so we're using Murata's lithium battery. That's the one that we use in our system. So we need 15-year warranty, and we have a 10-year warranty. So when we're talking about, we're not the cheapest battery storage in the market, but when we're talking about resiliency, again, bringing Puerto Rico a scenario, what happened here and what we have suffered after the hurricane, and we're talking about resiliency, this type of technology solves that problem. So we're right now currently installing around 1 megawatt of batteries in Puerto Rico for residential and small commercial. So there's a lot of potential for battery. People are getting more educated. I know the technology is changing continuously, and it will keep on changing, and prices will be lowering. But I think it's very important. It's going to be a very important part of Puerto Rico's new grid utilization. So that's in general on the battery technology that we have. I don't know if you have any other questions.
Yeah, a follow-on question I think is, maybe trying to get an idea of, where the costs are and where they're going. Depending upon, obviously the use case, like everything else, is dictating it. But the average small business or home or group of homes, you would if you wanted to optimize your system to basically net out most of your consumption from the grid. I guess the average would be about a 3 to 5 kilowatt system. Would that be one battery? How much would the battery be? What does this do to kind of the total cost of installing a system? The headline risk.
Yeah, here I'm showing right now here in the screen, our smallest battery is an 8 kilowatt hour battery. You can see on the screen, and we have four boxes with 2 kilowatt hour of batteries of storage. We could then put 12 or 16. 16 is the whole cabinet, and we can extend to 450 kilowatt hours. Okay, but the price, it's around $900 kilowatt hour, give and take. And again, we can use different technology. The difference from other types of battery storage, let's say a standalone system, is that we could design our system to the necessity of the client. So if someone wants energy backup, if someone wants off grid, if they want the generator also connected to the battery, we could be connected to the grid. So it could be designed in different aspects. So it fits to the necessity of the client. Okay?
And Daniel, I think being the kind of expert on storage systems, batteries in particular, we just sort of led into there to the different configurations, different uses. The maximum potential that you're getting out of a battery system tends to be something that is highly dependent on the battery management software. Isn't that correct? That's kind of where most of the gains or losses could come in terms of how you operate.
Yes. The life of the battery is dependent on how fast you charge it, how fast you discharge it, the temperature that you keep it at. The battery management system is very important in determining all of that. I do have a question for Gabriel. You show an 8 kilowatt hour, 16 kilowatt hour system. Can you break that out into the power component and for the duration? Is that like the 8? Is that a 8 kilowatt hour? Is that 1 or 2 kilowatts for 4 hours, or how is that broken out?
Yeah, let me share my screen again. Sorry. Okay. So this is the typical cabinet that we use. Is 24 by 24 by 39. So it looks similar to, let's say, a wine cellar. And an 8 kilowatt hour, if you see the screen, it's half of the cabinet with batteries. Okay.
But is that a 4 kilowatt for 2 hours to give you 8 kilowatts? What's the power capacity?
The power that it gives 8 kilowatt of power.
8 kilowatts for 1 hour then. Exactly.
That's the power that we give. And we start with 8 kilowatt hours, and we could go up to 450 kilowatt hours. The BMU, what you were mentioning, we have it here, the battery management unit, and our design is the one that support us and let us discharge the battery 100% without affecting the life of the system.
And all your systems, are they all the batteries going to be the lithium iron phosphate?
Lithium iron phosphate, yes. That's the technology that we're using, and we're using Murata cell. Murata just bought Sony's lithium company a couple of years ago, and so we're working with Murata. We're using their technology.
So one thing as a disinterested third party, Tom, should be noted that of the lithium ion battery fires that you see on the YouTube and the internet, I have not seen one yet that's a lithium iron phosphate technology. Right. Usually all with the cobalt technology.
Yeah.
No, that's that's the main thing, the safety factor. And just showing a quick video on an example of what you were saying, other types of technology, doing a nail penetration, and an example of cars hitting their battery storage in their, it could make fire, it could create fire. But the technology that we're using doesn't do that. So that's why you were mentioning, and just I wanted to bring that out, the safety factor, because batteries is growing, and fire departments is getting involved, permitting. It's gonna be more difficult eventually to put batteries in your homes. So what we're using the most safest technology. So you can see our technology doesn't catch fire. As the other one. So that's something super important, to mention here. Mm-hmm.
Yeah, I mean a bit of history, but Hank Rogers, who launched Blue Planet Foundation and Blue Planet Energy, is a bit of an entrepreneur, and he loves to test things out. So he took his ranch in Hawaii off the grid years ago with stacks and stacks of lead acid batteries, right? Just basically car batteries is the way he started when he got himself off. And he wouldn't convert to batteries, lithium ion, until he had found one that was safe. And so the configuration that they chose was the lithium phosphate for just that reason. Interesting.
I actually got to visit that his farm up there.
Oh, cool.
I haven't. I have an invitation, but I haven't had the opportunity. So that sounds like something to plan for in the future. I think coming back around. The different segments we haven't really looked at grid connected storage. Not necessarily the focus of this. We're not really talking about flow batteries or other battery developments that have kind of that 3 to 6 hour depth, which you kind of need for grid system response purposes. But having said that, there's a whole lot to focus on here. If I was going to break it down, and you guys can agree, disagree, fight over it. We started with the premise of batteries or batteries versus. It sounds like batteries and fuel cells, and there are kind of advantages and potential disadvantages that allow them to cover different segments. With the batteries, you don't have the potentially the supply line risks that are still exigent in relying on natural gas. At the same time, you don't have the benefits of siting and securing the heat and other CHP benefits of the fuel cells. We talked a little bit about cost and dispatch. Fuel cells are, certainly as Michael said, they're a lot more flexible in terms of dispatchability in relation to the grid and operations. We talked a little bit about cost with Gabriel. Michael, we didn't necessarily cover that in terms of cost per unit, cost for operation, and then kind of we talked about the smallest size, but you're not going to put a fuel cell in your home, probably.
No, not with Doosan. The smaller fuel cells do exist. They're mostly for cell tower backups, where there's a gas infrastructure or gas network. But with ours, we make a 460 kilowatt fuel cell. The price per kilowatt now, compared to many, many years ago, is around $5,000 a kilowatt installed with no incentives. If you were to take the investment tax credit, you'd get down to about $3,500 a kW, which is very, very inexpensive for that kind of power. And then when operations and maintenance, Doosan offers a comprehensive, what we call bumper-to-bumper service plan that's all-inclusive. There should be very little to no interaction between the facilities people and the fuel cell. I mean, it really just operates all day, every day. Most of our service is just changing out water bottles or filters. And I think it's important to note that we actually don't use a lot of water. We run in water balance. On a super hot day, we might take a gallon per minute, but we really don't try to use more than 2,000 or 3,000 gallons of makeup water in a given year, which is pretty remarkable for cogeneration. It's just another one of the environmental benefits to adopting fuel cell technology.
Absolutely. And Gabriel actually has a question for you. Obviously keeping the batteries cool in terms of performance is key, but it doesn't drop much below 75 degrees in most of Puerto Rico at any particular time. Does this pose challenges going forward?
Okay, so let me in the screen. Here the cost of the batteries our batteries don't have to be in air conditioning. They could survive the weather of Puerto Rico. That's something super important to bring. I did a solar farm here 5 years ago. And I think was the first solar farm connected to the grid with MTRs, with the batteries to PREPA. And we use SAFT batteries, and those batteries are with air conditioning 24/7. That was 5 years ago. Technology is changing, and our technology doesn't require us to be in air conditioning. So it's changing. Mm-hmm.
Does that well, with the new technologies, that's great. So you don't actually need the air conditioning. Does that affect the maybe not the performance curves, but the lifetime, or do we just not know from prolonged exposure just because of the newness of the technology and the environment?
Well, our batteries have been tested from Sony and Morata for a long time. That's why, just to give the 15-year warranty, these batteries have been tested for more than that. So the technology is there. Prices are coming down. Now we're getting there's safe technology. There's a place for these types of technology. People are looking for storage here, and if you're looking at commercial projects, big commercials and resiliency projects, people are looking also for safety.
Yeah. So Michael, maybe a quick question. Battery side, most people. Ooh, not sure what that was. Definitely getting feedback from somewhere. Hang on. Let me see if I can. I think, is that better? Yeah, that's better. Oh, maybe not. It might be Dan's. From the point of view of operations of systems, for batteries, most people looking at it tend to think about it as kind of set it and forget it. It's not 100% true. If you want to manage a system, you can set up the various operational algorithms, but in different cases, you're going to want to see perhaps more active management of battery systems when you're actually interacting with the grid. But for the most part, when you're looking at the operations of the things that have been mostly installed around the world, Is that true for your systems as well, or do they require more hands-on?
No, it's all automatic. I mean, we monitor all our systems remotely from our operations headquarters here in South Windsor. We can do a lot of predictive maintenance. It really should be set it and forget it. If there's load following, we can do that. We can interface with the building management software. Again, it's you wouldn't, if the fuel cell ever went down, you would not notice an outage at your facility. I mean, it would just trip to idle and disconnect, and there would never be a hiccup in the power flowing to the site. It's just really just another piece of distributed energy technology on your property.
So let me turn a second, and we're kind of looking at the future. And I just sort of hinted a little bit about it. The systems have been primarily designed with the idea of working within balancing a microgrid, whether it's desynced or whether it's currently synced with the grid. But going forward, as we expect, especially the Puerto Rican market to evolve perhaps faster than most places elsewhere, actually being able to interact with the grid and take advantage of positive arbitrage of what will eventually be time of day use and different rates and other types of tariffs. Responsive and reactive, power and payments and grid balance and that sort of thing. How are each of you guys thinking about the operating systems that need to be in place? Do they exist? Do they need to be developed? Do you think Puerto Rico is going to be a proving ground as the system transforms for proving out the operating capacity of these new types of operating systems for Puerto Rico and for other markets?
I can take a first stab. I don't think we're not going to reinvent the wheel. Whatever tariffs come out, I'm sure we'll be able to go with the flow. We operate, as I said, in a handful of states where there's dozens to hundreds of electric utility companies, where there's different rate structures, there's time of use, there's unlimited net metering, there's no net metering. I mean, we're just going to be producing power for the customer at the end of the day. I think when, on the flip side of that, if you talk about what the utility is going to end up doing or whatever the IRP is going to recommend or whatever Siemens is going to recommend for PREPA to end up doing, that still remains to be seen. That's where I think there's going to be more nuance, where perhaps they'll allow for more distributed energy resources to power the balance of the grid. But I think as of today, we're just looking to do behind the meter generation. I think getting in front of the meters maybe 5 or 7 years down the road. I mean, we just probably won't be able to compete with the large power suppliers.
Okay. Gabriel, what are your thoughts?
Yeah, my thoughts are, well, right now here in Puerto Rico, there's a lot of things happening here in Puerto Rico at the same time. First, the utility, first of all, is bankrupt. Okay, the monopoly is bankrupt, and right now there's a federal case, a couple of miles from where I am, working on PREPA's bankruptcy in Puerto Rico. So that's affecting a lot the financing and development of projects, and it has been affecting that development of projects for a couple of years now. And of course, PREPA's reputation. They don't have a good reputation here in Puerto Rico, and I don't think any monopoly utility company has. So people don't trust them. So there's a lot of trust factor. Also, the infrastructure doesn't work even before the hurricane. Now it's even worse. So then you start talking about the energy policy, the new laws are coming into place. So there's a lot of things happening at the same time. I think PREPA is going to be privatized, the generation factor, and other players we're going to come in to take that lead. Hopefully that comes soon, so we could have a more stable, a more reliable utility and offering, then we could get to more renewables and get to more economic, economic help the economy here in Puerto Rico that we're lacking of a lot of jobs and we need jobs. So there's a lot of things happening that are affecting this. But what I'm seeing that also from when you have a problem, when you have a situation, opportunities come. So that's why you have other people, wanting to support Puerto Rico. There's people that want to finance. There's things that are happening with the DOE also. So a lot of things are happening here, and I think I'm seeing the light at the end of the tunnel. That's the first time I can tell you from all my years in the industry. It's the first time that I can see, hey, we're moving slow, but we're moving to the right direction.
That's great. Yeah, I think I see the same thing, and hopefully others will too. So we've actually reached an hour. Wanted to make sure that folks on the line had an opportunity, perhaps, to ask questions. There's a chat feature if you can access it. For those on the phone, you can take yourself off mute. There's only a handful of people here, so I can actually take people, I think, off mute. If we don't all try and talk at once, we should be able to get in some questions. You can always chat them. So let me take people off of mute now, and maybe see where that goes.
Called last week. I was the leader in call.
Hello. So does anyone have questions for our panelist? This is just raptured. Well, let's maybe Dan. I don't know if you had any more questions for Gabriel or Michael.
There's a battery. There's a question here in.
Oh, here we go. There we go. Hey, Francisco. Thanks.
What are the main battery companies in Puerto Rico now? I think all the battery companies are right now in Puerto Rico. Everyone. Tesla, Paica, Simplify, Blue Planet, of course, and then we have lead acid. We have. You just mentioned Fortress. We have all different types of batteries here, so there's a great opportunity for the battery market.
Yeah. Well, there's also, maybe leading on to that, it's a good question, Francisco. I know a handful that maybe aren't quite there yet. The guys that are focused on some of the larger grid-connected stuff, like EOS in New Jersey. And one of the things I think that you will see as quite clearly as the market kind of unfolds and unsticks itself, is that you'll actually see more people investing in assembling or manufacturing batteries in Puerto Rico for Puerto Rico, take advantage of some of the tax benefits associated with locating there. But it's also a great place to prove these technologies and move the products and services into Latin America as well, which, by the way, Gabriel is very experienced at.
Yeah, and also we're trying to be one of those companies, seeing the demand that we're seeing here in Puerto Rico. Our plan is to open a facility here and start assembling the systems and take advantage of the tax incentives that Puerto Rico is offering and opportunity zones. So that's something that probably could happen at the end of this year, early next year. Mm-hmm.
That's
so Gabriel, I have a question for Gabriel.
Yes.
So what do you see the path forward to get more of your systems installed in Puerto Rico? Or what's the impediments to getting them installed?
Yeah, that's a great question. Uh, a couple of years ago, we used to have the Green Energy Fund. It was a fund from $220 million for renewable energy and batteries here in Puerto Rico. It started in 2010. And you could go over the list, and I don't think a lot of people submitted projects with batteries. Right now, the incentive program it's not working anymore because of the Puerto Rico bankruptcy. So I think now with the CDBG and funds, I think opening a new incentive program for people so it could be more accessible, the renewable energy and batteries. I don't think have to be a big incentives don't have to, because solar panels and other components have gone down, but still battery it's not in the number, it's not in the same league as panels and inverter pricing. So I think incentives and of course the legislation, the 1121 law, I think signing that law will be great. But again, PREPA, if we're connecting batteries to the grid, the permitting process has to be more reliable and trustworthy, because you submit a project to PREPA and even let's say a 1 megawatt project solar farm for a pharmaceutical, it takes you 2 years on a permit. So who's gonna wait for 2 years? A lot of things can happen in 2 years. We had a hurricane. So the permitting process and the financing, I think, is the last one. So incentives, permitting, and financing, those three things, I think they could be great for the industry.
Yeah, I think I'd add, well, maybe it's not a third category, but when I look around at the island and the markets being undeveloped, the incentives that Gabriel just mentioned is I think it's up to $6,000 per installation. They've targeted about $400 million or $450 million from the CDBG to support distributed generation, presumably with storage for resiliency. But to get more, I'll call it commodity finance, straightway, regular financing in, there's a level of discipline and capacity building that has to happen at the market. The counterparties need to understand how to build a good credit profile and a few other things, which is different from the fact that the state is bankrupt and uncertain. You can move projects at the residential and the commercial level, and from the permitting standpoint, it's worth noting that when the governor signs the bill, the commercial, industrial, and renewable advocates have been successful in placing into legislation a requirement that effectively any system under 5 megawatts should have its permits within 90 days. So there's a clock associated with that, according to the law. We need to see that in action, and we need to see the regulator and others back that up. But at the very least, I don't think we have to look to 2 years anymore. And so it may create a new, an even better problem that the companies who are putting these things in don't have enough bandwidth to deal with all the demand. But that'll be a nice problem to have.
So I have another question around the incentives. So there's this talk about I think it's $18 billion to come from the government to go to Puerto Rico to rebuild. Is that real?
It is real. And last week, HUD released another $8 billion, which, I mean, there's still some pathway to that, but they basically approved the release of the funds based on the outline that the government of Puerto Rico had given for how the funds would be used and where they would be channeled. Quite a lot of that money goes through Vivienda, which is sort of like the HUD of Puerto Rico, and a lot of it is for kind of basic housing and other infrastructure. But there's a little more than $2 billion that is specifically targeted at energy infrastructure. Some of it is funding the incentives for generation we talked about before, but the vast majority of that money needs to go to basically the PREPA, right, the grid company for rebuilding. And it's one of the reasons why you're not going to see a total privatization of PREPA. They'll do it by a concession for T&D, which is where the money's going, because that money can't go to a private entity. It's got to go through effectively the state and to PREPA to spend on strengthening and rebuilding the grid. Not all of it. It's not enough money, but it will get you to hopefully a point where the grid is more prepared for more distributed energy and with a lot more resiliency than it currently displays. That's still a short answer, and I won't say that I'm a total expert, just maybe a bit more attuned to it than others. Gabriel, did I get anything wrong in that?
You're correct. The thing is that from the CDBG, and that's the CDBG DR, Community Development CDB
Block grant.
Block
Disaster
grant,
recovery.
disaster recovery, exactly. So that happened in Texas, in Florida, in all the territories, all the states, jurisdictions that they were hit by a disaster. They're receiving those funds. Currently, even in Orleans, Katrina, they're still receiving funds from that program. The thing here in Puerto Rico is that the U.S. government doesn't trust the Puerto Rico government. Is, you know, and there has been a lack of the funds to deploy. It's taking longer than what everybody thought it would take. So I think it's more a political issue, but the thing is that we're still waiting, and everything is going a little bit slower. And again, if it was not for the non-for-profits, probably we were not even talking this panel, because 99.9% of the projects that I've been doing is been non-for-profits. So they're the ones that are really doing stuff here.
Yeah, and well, we're another nonprofit, but we approach things a little bit differently. We're trying to build the pathways and the capacities to allow the private markets and government to work more efficiently. You know, as we say, I think maybe getting slightly off topic, and you know, everything we've seen in the press, and you know, Donald Trump and, you know, Ricardo Rosselló, you know, would punch him in the mouth and all that kind of stuff. It makes for good political. But the truth is obviously more complicated. The concerns on the operational side are that the kind of infrastructure in government and the private sector that you have in a Texas or even Louisiana or elsewhere isn't developed to quite the same degree in Puerto Rico. And so when you know, put money in and see, it actually has to go through kind of a lot more hands in order to get something accomplished. So the money, the emergency money that did make it through into housing, for example, only a very relatively small amount, like 40%, actually went into building and rebuilding for the early money that went in, as opposed to maybe 60, 70 to 80% in others, just because the institutions, the pathways, and other things to actually get that money into use are not established efficiently for the purpose. So the legitimate operational concern from the CBDG is, you know, getting the money in, making it effective, and finding ways to make the use more efficient and the pathway to getting it to the final user. I don't have any quick fixes for that one, but we'll certainly be working on building it elsewhere. So Francisco had another question, and maybe this is certainly one for Gabriel, but maybe for Daniel as well. The shortage in battery supply. There's a lot of talk about it. I'm aware at some point last year there was difficulty in actually getting batteries delivered into Puerto Rico for installation. What's the truth of that?
Gabriel, you want to take first stab, or you want me to?
No, go for it, Daniel.
So, I think part of the problem last year was cobalt. The cobalt spiked, and there was, allegedly shortages of it. But since then, cobalt has become abundant again for whatever reason. The prices have plummeted. So I don't know of any shortage of batteries. Now, there are lead times in getting them just because of the manufacturing capacity. But, over in Korea, China, Japan, they have a pretty good manufacturing capacity. And then you have Tesla here in the United States with their Gigafactory. And so I'm not aware of any shortage of getting batteries now. There was a problem with the cobalt last year, but that's not a problem anymore.
Great. And in terms of fuel cells, I mean, these things are the Doosan machines. Can you buy them off the rack? Do you have an inventory? They're made in advance, or are they made to order?
They're made to order. I mean, we're manufacturing all the time. The typical delivery time is about 9 months, which is normal infrastructure project. I think, it's funding and the engineering and everything else that goes into it. It's an appropriate, I think, amount of time.
Yeah, I guess given the set kind of minimum 460 kilowatts, right? I mean that sort of thing requires usually a little bit of permitting, but it's 9 months in a distributed market and storage. I mean, does anybody think that in a market like Puerto Rico that could potentially be a problem in terms of 9 months? And is there a means of potentially speeding that up as the market grows and you got?
Yeah, I mean, I think there is an opportunity to do that. It just depends on the opportunity. I mean, we're looking for behind the meter projects, and this comes into Wright's notes. So yeah, it's just we're looking to do to accelerate that based on the opportunity, but I just don't know if we're there yet.
I did.
So yeah, I think it's a case by case basis is what we're looking at. So if there's a huge project that needs to be accelerated, sure. But I think 9 months is appropriate when you really think about what it takes to develop these infrastructure projects.
Cool. Excellent. Well, look, we've come to an hour and 20 minutes, and Francesco seems to have run out of questions. So I guess I'll just end this, by thanking my panelists, Michael Koskin, Daniel Bourne, and Gabriel Perez. And we will be taking this and eventually making it available. It'll probably end up on the YouTube channel for us. We will look to try and put in Spanish subtitles as well. Apparently you can do that, and we can get that done. And I want to thank again the people who have joined, and hopefully we'll be joined by everyone for the next webinar we do, which I haven't quite planned yet, but we'll get an announcement out soon. Thanks again, and I hope everyone has a great day and a great week.
Thanks, Tom. Thanks, everybody.
Thank you.
All right.